Okay, this is the chapter estimating parameters and determining sample sizes, and the first section from this chapter is estimating a population proportion. So we would like to estimate population proportion. These are the three key concepts we are going to discuss: point estimate, uh, confidence interval, and sample size. So point estimate is a single value which can be used to estimate about the population. So there are different type of point estimate like mean, standard deviation, variance, sample proportion. But in this particular section, we're going to focus on sample proportion. Sample proportion, and then the notation for sample proportion is p hat, as you can see here. And this is one of the best, one of the most consistent estimator, and it's unbiased as well. And estimation is called unbiased if the mean of sampling distribution is equal to the corresponding population parameter. That's called unbiased. So sample proportion is one of the unbiased and best estimator. So there is a confidence interval. When we estimate something, we have some level of confidence, and then there is a confidence interval based on that level, and which is actually the range of the values used to estimate the true value of the population parameter. Okay, and based on that interval we can create the confidence level, which is actually the probability 1 minus alpha. The confidence level is the probability 1 minus alpha that the confidence interval actually does contain the population parameter. So assuming that the estimation process is repeated large number of times, but that's the assumption we have to make. Confidence level. To find out the confidence level, we need information about the alpha, and here is the relation between most commonly used confidence level and alpha. For example, 90% means alpha is 10%, and 95% confidence level means alpha is 5%, and so on, so on. And in previous chapter we discussed about the critical value based on area under the curve, which is actually the probability. And then critical value means it's a g-score. So if area under the curve is let's say, for example, for this g-score, g alpha over 2, it means the area under the curve to the right of this g-score is alpha over 2. That's the meaning of critical value. How do you find it? You can find it using the technology like TI-8384 calculator. That's what I'm going to use. That's what I used. But you can also use table, the given table. If you have given table, then you can also use that for finding the g-score. So let's look at one example. If alpha is 5% and we need to find out the g-score for z alpha over 2, then alpha over 2 is 0.025, which is 2.5%. So for finding the value of z 2.5%, how do you do that? You can find finding the critical value of g-score. So this is we have given z alpha over 2. Here alpha is 5%, so alpha over 2 is 2.5%. The meaning of this is the area under the curve to the right of this g-score is 2.5%, which is 0.025. So for this area we need to find out the z-score. For that you can use a calculator, or you can use table. This is same as previous chapter where we discuss about the critical value. I'm going to use calculator while solving the problem, but that's what it means. So we get the confidence level, and based on the confidence level we can find out the alpha and alpha over 2, and based on that alpha over 2 we can find out the cumulative area from the left excluding the right tail, that one. And for that we're going to find out the g-score. So these are the some commonly used confidence level and alpha and critical value. So 90% confidence level means alpha is 10%, and g alpha over 2 is 1.645, meaning the value of the g-score such that the area under the curve to the right of that g-score, which is for the area under the curve to the right of that g-score is 2.5%, no 5%, because alpha is 10 here, so alpha over 2 is 5%. For that the g-score is 1.645. So these are the commonly used critical value. I'm going to show you how to use your TI-8384 calculator for finding that z-score. So up to now we're just trying to estimate about the population, and we're using proportion, sample proportion, to estimate about the population. And then when we estimate about the population, we have certain level of confidence, but even with the confidence we might have some error. That's called margin of error, and there is a way to find out the margin of error, and this is the formula for finding the margin of error. So we already know how to find the z-score, and then a square root of p hat times q hat. Q hat means it's actually 1 minus p hat. P hat is it's a proportion estimation, sample proportion estimation about the population. So by using this formula we can find out the margin of error, and creating a confidence interval with this margin of error is called Wald confidence interval. When constructing a confidence interval using the margin of error E given in the formula, the result is called Wald confidence interval. Okay, and how do we do that? So before we do that, let's look at the, let's interpret a confidence interval. So let's say there is a correct interpretation and many different and creative incorrect interpretation of the confidence interval. So for example, let's say this is our confidence interval. We are confident that the population parameter would be in between these two numbers, 0.405 to 0.455, with the confidence level 95%. The meaning of that is we are 95% confidence that the interval from 0.405 to 0.455 actually does contain the true value of the population proportion P. So that is the meaning of confidence level. But if we say there is a 95% chance, no, that's wrong. That's not the chance. That's just our confidence level. If we say that 95% of the sample proportion will be fall between these two numbers, that is also wrong. So the only thing you have to keep in mind is confidence interval only tells us how much confident we are about the sample population proportion to be in between two numbers. Okay, that's called confidence interval. Okay, so we need to construct confidence interval for estimating a population proportion. That's our objective. So how do you do that? First of all, let's make sure that we are using the same notation. P stands for population proportion, P hat stands for sample proportion, N stands for number of sample values, and E is the margin of error, and this is the critical value. So using those notation, we can we can find the confidence interval we can use the confidence interval for estimating a population proportion P. But these are the requirements we need to satisfy: 1, 2, and 3. The first of all, the sample should be the random sample, and then the outcome of the for the binomial distribution, the condition for the binomial distribution are satisfied. That means there is a fixed number of trials. That's one of the requirement, and the trial are independent, and there are two categories of outcome, and then probability remain constant for each trial. So these are the conditions it should meet to construct a confidence interval for estimating a population interval. And number 3 is there are at least 5 success and 5 failures. So these are the requirements we need to always check for the confidence interval for estimating a population proportion. So this is how we write confidence interval for the estimation. This is the estimation. This estimation would be inside this confidence interval. P hat, which is the sample proportion, minus margin of error, and P hat plus margin of error. So there is an estimation, you have P, and you want to you have the margin of error E. Then that estimation could be in between P cap minus P hat minus margin of error to P hat plus margin of error. So this P hat is coming from the sample proportion, and this is the based on our estimation, the population proportion should be in between these two values, and these are the formula to find out the confidence interval and then margin of error. And this is how we generally write down a confidence interval: P hat plus minus E. Okay, So when we try to round off a confidence interval, always round the confidence interval limits for p to the 3 significant digit, unless stated differently. So how do we construct a confidence interval? These are the steps we are going to follow. First of all, verify the requirement. These requirements are already met, and then that's the first step in. And then second thing, we can use technology. I'm going to use technology TI-8384 calculator for finding the critical value, and then we can use this formula for finding the margin of error. And using all this information and this formula, we can now calculate a confidence interval p cap minus p hat minus e and p hat plus e for finding the confidence interval. Finally, round the resulting confidence interval limits to the 3 significant digit. That's what we're going to use for rounding. And when we analyze the polls, there are certain things we have to consider. The first one is the sample should be a simple random. The confidence level should be provided. The sample size should be provided. These are the things should provide when we analyze the polls. And then except for relatively rare case, the quality of the poll result depends on the sampling method and then size of the sample. But the size of the population is usually, we don't care about the size of the population. Okay, so this is the caution. Never think that poll results are unreliable if the sample size is a small percentage of population size. The population size is usually not a factor. And if we have given confidence interval, using that confidence interval, we can find out the sample estimator, because we know the confidence interval is p hat minus e to p hat plus e. So if we add these two ranges, then we're going to find out 2 p hat. So to find out the sample estimation, this is upper confidence interval, which is this one, plus lower confidence interval divided by 2. That gives you sample proportion. And for the margin of error, if you subtract this one from this one, then that will be 2 of the margin of error. So if you have given confidence interval and if you want to find out the margin of error, it's upper confidence interval minus lower confidence interval divided by 2. Okay, so sometime we also need to find out the actual sample size to get certain confidence interval or confidence level, and for that we have to use some formula. So let's get back to the notation. These are the notation we are using, and based on that notation, if sample proportion the estimation is already known, then this is the formula we're going to find out, we are going to use for finding the sample size. If no estimation is given, then this is the formula we're going to use for finding the sample size. Okay, remember, whenever we whenever we work with the sample size, always round, there is a rounding of rule, always round your sample size to the next larger whole number. Like for example here 708.135 can be should be rounded to the 709. Okay, so here we only discuss about one way for creating the confidence interval, but there are bunch of other ways as well. There is not universal agreement on which method is best for constructing the confidence interval estimating of population, but here we just discuss about one one method. Okay, so now based on this information, let's do some examples. Okay, a newspaper provided a snapshot illustrating poll results from 1910 professionals who interviewed job applicants. The illustration showed that 26% of them said the biggest interview turnoff is that the applicant did not make an effort to learn about the job or the company. The margin of error was given as plus minus 3 percentage points. What important feature of the poll was omitted? If we check our notes here, when analyzing the poll, these are the following things should be considered. The sample should be simple random sample, it's given there. The confidence level should be provided, but in this particular problem, as you can see here, there is no confidence level, so the confidence level is not provided here. Okay, express the confidence interval. This is the confidence interval we have given and we would like to express this as a p cap p hat plus minus e. Okay, so if you go to this one, as you can see that we can find out p cap by using this formula by adding upper confidence interval plus lower confidence interval divided by 2, and then we can find out the margin of error, which is upper confidence interval minus lower confidence interval divided by 2. So I'm going to do the same thing here. We have given upper confidence interval and then lower confidence interval. So p cap is actually, it's a addition of upper one, which is 0.888 plus the lower one, which is 0.444 enter, and divided by 2. That gives us p hat, which is 0.666. So how do you find the margin of error? According to this information, it's a upper confidence interval minus lower confidence interval. If you subtract the lower one from the upper one, which is in our case it's a 0.888 minus 0.444, that gives us 0.444 divided by 2, and that is our error. So 0.222. Okay, I might have to do something from here. Let me check. These are the notation. We already know the meaning of the notation. We can always check. Okay, let's do this one, or maybe, yeah. So let's do one of this. How do you find the critical value G alpha over 2? So remember, G alpha over 2 is a G score such that the area under the curve to the right is alpha over 2 for 88%. So as you can see here, if you go back, the relation between alpha and area, where is that? This one. So based on the confidence interval, you can find the alpha, which is opposite of confidence level, and based on that alpha we can find alpha over 2, and then we can find the G alpha over 2. Okay, so how do you do that? In this problem, alpha is 88%, 100 minus 88%, which is 1 minus 0.88. That is alpha, and alpha divided by 2 is alpha over 2, which is 6%. So the critical value is the G score such that area to the right of that critical value is 6%, so 0.06. Here in this TI-83 plus calculator, if you use second and then variance, and if you go to number 3, which is inv-nerve, it takes the area to the left of the G score and it gives the G score. But this is the area we have to the right of the G score. So if the area to the right of the G score is 6%, the area to the left of the G score is 94%. So it's a inv-nerve 0.94. Where is that? It means when we enter this, it gives us the G score such that the area to the left of this G score is 1.55. okay, you see that 1 minus this area, this 0.06 is 0.94, and that's what we have done here. You have to subtract alpha over 2 from 1, and that gives the area under the curve to the left, and by using this function inv-nerve, it gives you the G score. So the G score is, if you round it to the 2 decimal place, it would be 1.55. 1.55. That's the G score. Okay, so let's go to next problem. Yeah, this is the interval, so we can find out the point estimation. What is that? Okay, so let's do this problem here. In a recent tennis tournament, women playing singles matches used challenges on 134 calls made by the line judges. So among those challenges, 38 were found to be successful with the call overturned. So construct a 95% confidence interval for the percentage of successful challenges. So first of all, we have to understand the problem here. So they let me just use some blank pages here. First of all, we have to understand the sample and the estimation we're trying to do here. So based on this sample, out of 134 calls, made by the judges, among those challenges, 38 were found to be successful. This is just a sample. Based on this sample, we would like to estimate about the whole population. So for this, the point estimation p hat is equal to, out of 134 calls, 38 of them were successful. So this is the estimation. So if you just divide 38 by 134, 38 divided by 134, that's 0.28. that's the estimation. This is the 28.35%. So 28.35%, 35, if you round it to the two decimal place, it's a 36. So based on this sample, 28.36% times, whenever in that matches, whenever the line judge made some call, out of 28.36% chance time that the decision of the judge was challenged, and that was a successful challenge. So this is our sample proportion. So based on this sample proportion, we would like to construct a confidence level, and if you go to the confidence level should be sample proportion minus margin of error, and that's a lower bound, and then upper bound is sample proportion plus margin of error. So we need to find out the margin of error. We need to find out the value of E. So what is the value of E? If you check your formula for the value of E, where is that? Value of E, there is a formula for finding the value of E, this one. Okay, E is Z alpha over 2 square root of P cap Q cap divided by N. So for this case, in this case, first of all, for finding the value of E, we need Z alpha over 2, which is critical value. So in this case, alpha is 95%. So critical value is, we need to find out the Z score for that. So let me write down that formula, this one. Okay, so this is Z alpha over 2 square root of P hat Q hat divided by N, which is the sample size. So in this case, in this problem, alpha is 5%, alpha is 0.05. So alpha over 2 is 0.025. So we need to find Z alpha over 2. That means we need to find out the G score such that area under the curve to the left of this G score is 97.5%. So area under the curve to the left is 0.975. So for that one, by using very similar trick, go here second and distribution, go to number 3, that is inv-nerve. That means it's for the normal distribution. If you give the area to the left, which is in this case 97.5, the G score for this one is 1.9599. so that's a G score. So it's a 1.9599. so this is 1.96. Now using this formula, if we use this formula, users have to multiply the Z score times it by square root of P cap. It's already given, which is 0.28 36. Q cap, what is Q cap? It's 1 minus this value, 0.2836, and divide by N. N is the sample size. Sample size in our case is 134. So I'm going to use this information here in the calculator. So I'm going to multiply this G score by square root. Square root is this one, and then multiply the P cap, which is 0.2836, times it by the complement of that. If you subtract this one by 1, what do you get? It's 1 minus 0.2836. I'm going to use double parenthesis, and then divided by n. N is 134, and parenthesis close. That is our answer for margin of error. What did I do wrong? Okay, let me just calculate 1 minus 0.2836. That's our Q cap. So Q cap times P cap is 0.2836 divided by 134. That's a divisible by n, and take the square root of this value, square root of this answer. Where is the answer? This one, second. And take the square root of that and multiply it by the g-score. G-score is 1.96, and that gives us our value of E. This is the E. Okay, so now this is the E. Margin of error is 7.6%. so margin of error is 0.7631. so this is the margin of error. So for finding the confidence interval, you just have to subtract the margin of error from simple proportion, which is 0.2836. so 0.2836 minus this margin of error, which is 0.0763. So if you do that, it gives you the lower bound, but we need that in percentage. So it's in decimal, so for the percentage, just shift this 2 decimal to the left, so it will be 20.7 for the lower bound, 20.7. By using the very same thing, we can find out the upper bound, but you need to add p hat with the margin of error. So let's go back here. Our margin of error is 0.07631. So 0.0763 plus p hat is 0.2836. Just add them. It will give you 0.3599. If you round it to the one decimal place, it would be 35.9. So it would be 36, because if you multiply it by 100 to convert that into the percentage, it would be 35.99%. but if you round it, if you want to round it to the one decimal place, there is a 9, so you have to change this 35 to 36. So that's how we can find the confidence interval. Okay, so now based on this confidence interval, what we can say: since the upper confidence limit of the interval for women is higher than, okay, what is that? So for the part B, compare the result from part A to this 95% confidence interval for the percentage of successful challenges made by the men playing singles matches. So their estimation is the confidence interval is from 25.7% to 40.8%. Here for the women it's a 20.7 to 36%. So as you can see here, they are overlapping. So confidence interval means it's just estimation. Our estimation is 95%. We are 95% confidence that the population estimation would be in between these two number. And for the part B, our estimation is we are 95% confidence that population estimation would be in between these two percentages. But estimation doesn't say that there is a chance, there is a for sure they can say. So the value could be anything in between these two percentages. So as you can see here, this range, this interval, confidence interval is overlapping. So because of this overlap, we cannot say for sure which one is better. Okay, so let's based on that information, let's read the information we have given. Since the upper confidence limit of the interval for women is higher than both lower and upper confidence, since the two confidence interval overlap, neither gender appears to be substantially more successful in their challenges. So that's the thing you always have to keep in mind about the confidence interval. It does not tell you for sure that the answer should be there will be the chance the answer should be in between those numbers. It's just estimation, and if your estimation is overlapped, then you cannot say one is better than another one. Okay. Let's look at another problem here. Okay, a New York Times article reported that a survey conducted in 2014 included 36,000 adults, with 3.68% of them being regular user of e-cigarettes. Because e-cigarettes use is relatively new, there is a need to obtain today's uses rate. How many adults must be surveyed now if a confidence level of 95% and margin of error 1.5% are wanted? So here we need to find out the sample size. In this first case, assume that nothing is known about the rate of e-cigarette usage among the adults. So for this one, if you go back and check your notes here, the formula, there is a two formula we can use for finding the sample size. Where is that? Okay, these are the two formula. When an estimation of population sample estimation is known, this is the formula we are going to use. If the estimation is not known, this is the formula we have to use. In both cases, you can see that you need to find out the critical value, square it and divide it by margin of error, square of the margin of error. In first case, you have to multiply it by p hat times q hat. In the second case, you have to multiply it by 0.25. So let's do this problem here. For finding the value of n, you need to find out the critical value, z alpha over 2, and then margin of error. So as you can see here, this is the sample size, 36,000 adult with 3.68% of them being regular. How many adults must be surveyed if a confidence level is 95% and margin of error? So margin of error is given. So based on this confidence interval, the value of alpha is 5%. So alpha over 2 would be 0.25. So for finding the z alpha over 2, you can go here. You can use second and variance, which gives us distribution. And number 3, we need to find out g alpha over 2 such that the area under the curve to the left of that g value would be 97.5%, 0.975. And so g score is 1.9599. So this formula says, okay, use this one, second one, because no estimation is known. So you square it and divide it by e square. So square this g square. So I'm going to use this square and divide it by margin of error. In our case, the margin of error is 1.5 percentage points. Remember, 1.5 percentage means it's a 0.015. So it's divided by 0.015 whole square, and that gives us g square over e square. And because there is no estimation known, we are going to multiply this by point, look at here, the 0.25. That is the the sample size. But whenever you try to find the sample size, you always have to round up to the nearest integer. It's a 4268 point. That's why the nearest integer would be 4269. Okay. Remember, if the result from here it's already known, then we need to use this first formula. The first formula is same as before, like you have to find the g score, square of it divided by e square. So I'm going to use the very same value, 170.73. It's a 073.15034. This is the value I'm going to use, but I need p hat, which is sample estimation, sample proportion. So in this case, the sample proportion is 3.68% of them being regular e-cigarettes. So that's the sample proportion. So p hat is times it by 3.68%, so which is 0.0368, right? And then that's a p hat, times it by 1 minus that p hat, that gives you the q hat, which is 0.368. I can do this calculation outside, but I'm doing everything here at the same time. So that gives us 605. If you round it to the nearest next integer, it would be 606. 606. So as you can see here, without prior estimation, the sample size needed is 4269, and with prior estimation the sample size needed is only 606. Based on this information, does the use of the result from 2014 survey have much of an effect on the sample size? The answer is yes. Using the result from 2014 survey dramatically reduce the sample size. That's the right answer. Okay, let's look at another problem. Fill in the blank. Dash is a single value used to approximate a population parameter. That's called point estimation. That's the definition of the point estimation. Let's go another one. Which of the following is not a requirement for constructing a confidence interval for estimating the population proportion? So when you try to construct the confidence interval, there are some requirements you have to fulfill. Procedure for constructing, where is the requirement? There is a requirement. Okay, these are the requirement. The sample size should be simple random. The condition for binomial distribution should be satisfy. So these are the requirement. So there are a fixed number of trials. Yes, there are at least 5 success, 5 failure. That is also right. The sample is a simple random sample. That is also right. The trial are done without replacement. No, that's not right. Okay. So yes, that's the problem from this section.